All right, welcome back. We are Game 2007. That's multiplayer game design 1 in the winter 2026 semester at Georgian. And it's week 3, part 2 of our broadcast and recording. In the last part, we did a couple things. We talked about RPCs. We also did some skinning. We fixed our spawn points, all that kind of stuff. And now what I want to do is I wanted to do interaction with the character. How do we do that? So the first thing is we need to have some kind of input that allows us to interact. I'm going to use the E key to interact with things. Because it's a very common key to use. So that's what I'm going to do here. So IA interact is what we need to put into our project, which is a new input action. We've done these things before. So I'm going to input actions, add in a new input action. And there should be right here. And then I'm going to do IA interact. It's going to be a key. That's a Boolean, and that's OK. I can keep it the same way. And then what I'm going to do is I'm going to go into my mapping context here, and I'm going to add in a new mapping for the interaction. So there's my interact, and I'm going to choose the E key for interaction. There he is. So save. So you should be able to do that just as fast as I did. Adding actions and input actions for you, it should be no issues. All right, so now that we have a action and we've done this mapping, what I want to do is, for now, I want to add in IA interact input action event. That's going to be somewhere down here. One thing to note is this. I ran into a forum lately, and I'm not sure if you guys read any developer forums. I do, because I'm a nerd, right? I know, right? And one thing that I found, which is really cool, is that people who use Unreal Engine, they actually use multiple event graphs, right? Because it's totally cool. So right now we have an event graph that's here. You can see that in one event graph we have this part. You can add another one. What some people do, instead of calling it event graph, because it's still the event graph, right? But they partition it. So they put all their input actions in one graph, right? So that they don't have to clutter their graphs up with stuff. So it's a way, I'm talking about this with you. So if you want to organize yourself, as long as your partner and your partners in your game align with it, you can have multiple graphs. Now, positive about that, multiple graphs allow you to, to organize. Negative, if people don't know you have, multiple graphs, they're going to be like, "Where's your code?" Because they won't see it. All right, so I'm just letting you know that it's possible. I'm going to keep mine the same, but just FYI, that's a way of organizing, especially when you don't want to do this. All right, when there's a lot of stuff going on, and you want to put some of this, which is input actions and stuff like this, inside of another graph. Same thing with if I wanted to separate, and you can call these graphs whatever you want. For example, if I wanted to say something like sprint as a graph, then I can put all my sprint related stuff, which is all this and this, inside its own graph, which might make it easier for you guys to understand. All right, anyways, back to what I want to do here. I'm going to keep the same graph, and I'm going to do IA underscore interact. That's the interact event. And in the interact event, I can start and stop and whatever. And for now, it's, what I did to test it, to make sure it works, is, this button. I'm not going to do that because I know it works, okay? But we know that I want to interact, but I want to be able to interact with multiple interactables, okay? I don't want just to interact with the door that I'm going to use today. I want to interact with an item. I want to pick it up. And one thing we're going to do for our second assignment, or is it a second assignment? Is create an inventory, right? In multiplayer. So I want to be able to interact with the items that I want to put in the inventory. So I want to interact with them too, right? What about if I want to interact with a character? That's another interaction. So I can interact with multiple things. And so we need an interactable interface. So that's what I want to do. It's better than hard coding and tight coupling my interact functions. And the other thing I also want to be able to do is when you make something, when you implement an interface, you change the class, it now becomes colored or tinted with that new interface. So I can check to see if that class implements my interface. I can check to see if it's interactable. So I can say, is my interface interactable? Is my class interactable? Yes, interact. If not, don't interact. Which makes it a lot easier for me. Remember I talked about computational kind of awareness in terms of computational, how expensive things are. And this is another way of doing that. And it also makes this more flexible. So I want to make this, I want to call it BI for Blueprint Interactable, or Blueprint Interface. Interactable is what I want to make. And I want to make this inside of an interfaces folder. So again, under Blueprints, I have this. I want to make a new folder under my Blueprints folder called Interfaces. Inside my interfaces, I want to make a brand new, if I go to Blueprint, I can go to Blueprint Interface, and I want to call this BI Interactable. Interactable. There we go. BI Interactable. Now the Blueprint interface looks like this. We did an interface before in C++. Now we're just doing it in Blueprints. Okay. And if I double click on this, what you get by default is a function. Every Blueprint interface has at least one function. And of course, this is going to be something like interact, which is what I want to make, right? So let's make the interact function. Now, one thing to note about interfaces, I will not create details from my interface. The interface is just a declaration. We've done that before in C++. And then in the implementing class, that's where we make we define our our interact function. Does that make sense? So that's all I need to do. Starting off, I make an interactable interface. I have an interact function, and that's the first thing I need to do. Okay, good. Now there is another function here that's can interact, right? I could create a second function. We're not going to use this function. I'm going to come back to that. I'm just going to show you can make more than one function. We'll call this new function can interact. And by the way, these functions, you can add things to return. Like can interact clearly should return like a Boolean or something like that, right? So the outputs might be a Boolean, right? We'll call this value. Can interact, right? So that's something that you can define here, compile and save. And the other thing is for the interact function, we want to interact with a character or something like that. So we want the interact function to have a character instigator of type character object reference. Let's do that. So back to the interact function, we can go to inputs, add an input, which is called character instigator. And that will be of type character object reference. Character object reference. There we go. So we can define stuff for our functions just like we would any other time. So there's our interact. You can see it takes something. It doesn't return anything right now. Where can interact does return something. Okay. The can interact also can take a character instigator. Let's do that. So let's do can interact. We'll have an input, which is character instigator. Okay, there we go. Of type character object reference, right? That's what this is. Yeah.
Why don't you just do the MP playo?
MP who?
The main playo class.
Because what if I have other types of characters, right? I want to keep flexible. So because MP player is a character, but I can have other characters like enemies. Enemies could be a character type because I want to move them a certain way. So they have the character shape. They might have a character movement component, right? So it could be anything. What if I want to interact with a potential enemy, and when I interact with them, as an example, or they interact with something else, they trigger the interaction, right? So that's why. Keep flexible. You could also even step it further. You can say like instead of character pawn, right? Which means all kinds of stuff it'll include, right? Compile and save. But I like your question. That's good. It's good interact. It's good understanding. So now that we've done that, right? So I've made those two functions. I have my interface. We can close this now. I don't need it for now. But what I want to do is in my MP character, I want to be able to perform a sphere trace. Now we've done this exact function in the third person perspective project we did before. We're just doing it again. Last time we did it in C++, and now I'm doing it in Blueprints. So you can see it in Blueprints. Okay. So what I want to do is I want to make a new function called perform sphere trace. Let's try this out. And that's in here. Okay, so here it is. My perform sphere trace doesn't take any inputs, right? But what I want to do is I want to have 3 sequences, so 3 sequence lines, if you will. So I'm going to have a sequence node, and I want to have 3 input pins, or output pins, if you will, execution pins. And the first one is I want to set the start location, you know, as an example. I want to set the start and the end location for my sphere trace. That's what these things are. So set start location, I'm going to get an actor forward vector. So I want to get that. So get actor forward vector, and this is for my character. And then what I want to do is I want to multiply it by 150. So multiply it by, and by the way, if you get multiplied, I selected the wrong node. If I multiply like this, and notice you get a vector, but you can right click on here and you can change it to a float, right? So you can multiply by a vector by a float, that's okay. I multiply by 150. And then I want to get the actor location, get actor location, and I want to, you know, kind of add this. So I want to add, and again, if I take this as a vector, the result from this one is a vector. So I'm adding 2 vectors together, right? These 2 vectors. So what am I doing here? I'm saying, so start where my actor starts, and then I want to get my forward direction where I'm pointing, where I'm looking, and I want to add 150 centimeters to it, and that is my start location, right? That's what my start location is. So I can promote that to a variable, right? And now look at the type of variable. Is it got a V on top of there, right? Well, it says local functions here. Start location, and location. They're local functions. This is just an older version, so I want to say promote to local variable, right? And this local variable is going to be called start location. And it makes sense it's a local variable because we're not going to really need the start location of my sphere trace. That's the entire function to know, or the entire blueprint to know about that, right? We only want to share the variables with things that need to know about them, right? So here I'm just going to connect this up, and I'm going to use a reroute node and draw that thing a little bit. And this is like basically set the start location. So set start location. This is the start location of the sphere trace. There we go. All right, so that's the first one. And similarly, I want to do the same thing. I want to get actor location. Well, here's my start location. And then I want to get the actor forward vector and multiply it by 500. So this is the same. This part, these 2 parts are the same. And I also want to get the start location. So here's my start location. And I want to add those together. I want to get the add node here, just to make it easy, and just do one of these where I add these 2 things together. So what this is doing is it's saying, hey, where am I start? I start here, and then add in an additional 500 units. That's what it's going to do. It's going to project 500 units ahead of me, and this is promote to a local variable. This is the end location. So end location, right? And then this will be, you know, set end location. So set end location. There we go. And I also want to code that as black, and I want to use my execution pin. Oops, close this off. Use my execution pin with a reroute node here. Yeah, with a reroute node here. There we go. And now I have my start and end location as 2 local variables. Yay. The next part I want to do, going to go to the next slide, is a little bit more complicated, but not much. I want to sphere trace by channel, right? And I want to create a sphere radius float. So here, locally, I want to make a sphere radius, and I want to call this a float type, compile and save. And I'm going to set it to 50 units. Okay, so 50 units, compile and save. And what I want to do here is I want to sphere trace by channel. So sphere trace by channel. This big function has lots of inputs. we need the start and the end. So here's my start. Here's the end. Here's my radius. So I got all those inputs. There we go. Right? And you can see those are all local variables that I'm using. Right? And then it's visibility channel for one frame. And trace complex, I want to check on. Sorry, no, I think I want to check it off. Ignore self, and I think we've got everything that we need. Yeah. Okay, so that's the first thing. So we kind of perform a sphere trace. Now we want to make the sphere trace visible, so I want to take the out hit. Oh, this is a multi-sphere trace by channel. Sphere trace by channel. I don't want to do a multi-sphere trace by channel because I just realized I'm getting an array, so I don't want that. Saw right away. I was like, wait, that's not right. I'm getting an array out, and I don't want an array. I want a single sphere trace. Otherwise, I'm going to cast multiple spheres. I don't want that. That's crazy. So I want to kind of, break my hit result. That's what I want to do. When I break my hit result, it allows me to get all this stuff. And what I want to do is I want to branch. I want to check to see if I have a hit actor, right? And so here's my hit actor down here, hit actor. And what you can do is you can get the class of the actor. So hit actor, get class. And this gives you whatever the class is of the actor. And what I want to do is I want to, if I want to check to see if my class implements my interface. So I want to say is, if I say implements, does class implement interface, right? And the interface that I want to check is bi underscore interactable. So what this does is it checks to see that the actor I'm interfacing with, that I'm casting, and the actor that I'm hitting is something that's interactable. That's what I'm doing there. Okay? If that's true, then branch. Here we are. Here's the branch. If that's true, I'm going to go way up here. And what you can do is you can collapse the stuff I don't need. I do need the impact point of this one, so I do need that. If that's true, then what I want to do is I want to draw a debug sphere, as an example, of type sphere, of amount sphere radius. So let's do that. So up here, if it's true, I want to draw debug sphere. There it is. Draw a debug sphere of radius, sphere radius. And where I wanted to draw it is at the impact point. The impact point itself is going to be somewhere where I want to draw the sphere. It's not pretty. You could do things like save the impact point as a local variable and do it from there. If you want, I'm just going to make it like this. Still okay. Not so bad. One thing to note is the line color. Instead of line color being this, let's make it something that's very clear, like magenta. That's the sphere I'm going to draw. And the duration is going to be both 0, 0, so this thickness is going to be 0. And then what I want to do is I want to take that hit actor and I want to save it as an interactable actor, right? So, and the interactable actor is going to be of type actor object reference. So if I was to take that hit actor, right, as an example, the hit actor, if I hover over, it's an actor object reference. So I need to do this. Now it says for this section, you also need to create a class variable. So this is not a local variable, but a class variable or a blueprint variable called interactable actor, which is going to be of type actor object reference. Actor object, here it is. And once I've done that, then I can just set that. So I can set this here. You could have also promoted this variable here and called it that, but I'm just doing it this way. And it's just going to zoom out here. So you're going to just do some reroute nodes so that they are a little bit easier to read like this. Now here's something I could do, right, to cut down on some of these wires, because I'm not a wire guy. I hate wires, right? Is you could promote more stuff to variables here, like this local variable, if you really wanted to. And for the simple reason that you want to, make so that the reroute nodes aren't crazy, but you can make it somewhat organized. All right, so that is the performing the sphere trace, and it says if near enough to interactable objects, set the interactable actor. So if near enough, set the interactable actor. That's all I'm doing. And we can move this a little closer, zoom in, move the reroute node a little bit out, and not bad. So that is perform sphere trace. This function sets the start and the end, and it performs and draws the sphere trace. That's what it does. Now, once we've done that, we want to do this every frame, just like we did before. So in the event tick function, right? So again, if you don't have it, you can always go like this too. You can always go event tick, and if it exists, it'll take you there. If it doesn't, then it'll just make it for you. So here's perform sphere trace. There it is. And now if we just do this for a second, just this, and if I press play, and if I run it with, this guy, right, then we should have seen this interactable, this thing come up. And we're not seeing it. Let's take a look and see why. So going back up to here, this is this, and what I want to do is I want to draw a debug sphere, right? One thing is draw time for one frame. Let's make sure I have that. Sorry, I missed that part inside of this. So this one is for one frame. The draw time is 5 seconds. And if I do that, compile and save, that's the part that I missed. Then now we should be able to see these things. Now notice if I hover over something, it's green. That means I'm colliding with something that's positive. And we've done this before. But when I collide with something that's an interactable actor, it should be magenta, which is kind of what we did before with the sword in the last project. All right? So that's what this does. But now what we need is we need something that's interactable, right? That's what we're going to need. So when we want to interact, we need to interact with the server. So let's make a new interact event. We're all prepping right now for the interactables. Okay? So perform interact on the server. So again, back to this. Okay? And I don't want to be here. I want to be inside of my event graph. And down in here, I want to make a new custom event called perform interact server. Right? So this is where that's going to go. So new add custom events. I'm going to call it that, perform interact on the server. And what I want to do, of course, is run on server. So click onto that, run on server. And I want to check it as reliable, 100% on this one. And we also want to have an interactable actor of type actor object reference. So interactable actor. Yeah. Of type actor object reference. Oh, if I can spell actor, which I can't spell anything today. There we go. So that's what I got with my perform interact server, right? So that's the first thing. So this will run on the server. It replicates, right? That's important to do. And what I want to do is when I press the interact button, right? That's when I press the interact button. Whatever that interactable actor is, I want to perform the interaction on the server. Yes?
I have a really stupid question.
Yeah. It's nothing stupid.
Is it for visualization? Why are we doing the check with the sphere's trace?
Visualization. Yeah. Because we're debugging first. We want to see that we can see the things, and we can turn that off later, right? Which we would. It's not a stupid question. It's a good question. So interactable actor, which is what we want to have. We want to check to see if it's valid, which is up here. So we check to see if the interactable actor is valid. This means, is it null, right? Is valid. Now here's something else. There's a couple of valids. There's is valid. We can check that one. We can also do this one, is valid, this way. We can check that one. And we can also do interactable actor, and we can check this, change it to a converted to a validated get. So which one should we use? We can use them all,
Is there
right?
a difference between,
No.
like, performance-wise?
No. No. So basically it just gives you options. That's what this does. If you want to use a branch, an if statement, then you would use the first one, the green one, is valid, right? If you want to just use an execution pin, notice that this one requires an execution pin. This one requires an execution pin. This one does not. But this one requires a branch, right? Which does require an execution pin. And it gives you true, false, right? Is it true or not? Is the actor valid or not? This one is if it's valid or not, right? So again, very similar. One resolves, it returns the interactable actor. At the same time it does this. So realistically, even though the PowerPoint says to do one thing, let's try it this way. And let's see what happens. Okay, so I want to use a validated get instead of this, right? And this will be on started. So check to see if the actor is valid. That's what it's going to do. If true, then what do I want to do is I want to perform the interact on the server. So I want to take this perform interact on server. So perform interact server, this one, right? And because we have the interactable actor here, I can just go this, boop, right? Where I don't have to do separate things like this. Check twice. I don't have to do that. So this is also a way of doing it. Even though I did it differently, I'm using a validated get. And because we're doing this, direct passing, it makes sense. Compile and save. By the way, if it doesn't work, we can always go back to the other way and check and see what the difference is. There is no difference. Okay, it's the same thing. All I'm doing is checking to see if something is null. If it's not null, then do this. If it's null, do this. All right, so that's what this does. And we don't have an interactable actor yet, so let's create one. Okay, so that's the thing that we want to do next. So what I want to do is I want to make an interactable actor, and I want to make a new door. So I want to make, let's make a new door, and I want to put this inside of another folder. So again, under blueprints, we have interfaces. Let's make a new folder called interactables. There we go, is interactables. Inside there, I want to make a new actor blueprint. So again, blueprint class from actor. And we're going to call this BP underscore, I believe I called it wooden door. We're going to change this in the future. Wooden door. Yeah, I did that. And under wooden door, we want to add a static mesh. So add static mesh. Here it is. And I want to make this static mesh, I want to make it so it's the root. Let's make it the static mesh. I didn't do that in the PowerPoint, but I think it's the right thing to do. And now that I've done that, notice that the object itself replicates. So if I go to this, then you can see that net load on client, but I want to click on replicates itself. Otherwise, it won't show up for both. That's bad. Also, the static mesh component, which is different. If I hover over and just search for it, then I also want to make sure the component replicates. I want both replications. So not just the object, not the blueprint itself, but also the static mesh inside. Compile and save. I'm being a stickler. I don't really have to do this. So that's the first thing. Okay, so now in the static mesh, let's use the door. And if I type in the static mesh, and if I type in door, you're going to see that there is a door static mesh, right? There's a wall graded door, a bunch of doors that we've given. I'm going to use this one, all right? And here is the mesh that I'm going to use, right? Compile and save. And so that's what we're doing. We're just using the door option, right? And I want a variable named door open of type Boolean. All right, so let's do that. So variable, we'll call this door open of type Boolean. Okay, and one thing that I want for the door, it says in details panel, set the replication property to be replicated. All right, so again, click on the door open, and then on the right, wait, do I replicate it or do I choose a on rep notify? There's two, right? There's rep notify and there's replicated. Let's do replicated this time, okay, instead of rep notify. So what it says, if you hover over, should this variable be replicated over the network or not, right? One of them is if rep notify is on, it creates a little function, and that function gets triggered when it changes. That's what that does. Replicated just means that the Boolean exists in both places, but doesn't trigger any function. Okay, so that's the difference between the two. Notice that there's also a replicated condition on the right, where you can choose initial only, owner only, skip owner, simulated only, a bunch of other stuff. We're going to leave it with none. Okay, compile and save. And that's the first part, so the door interactable. Next, what we want to do is we want to go to class settings and we want to implement that interface. So I want to go to class settings and I want to go down to implemented interfaces and I want to click on add and we want to type in BI underscore interactable. There we go. So now the door implements the interactable interface. It has two new functions, interact and can interact. I told you we're probably not going to use can interact right now, but interact, it does have it here, okay? And that's what we've done here by changing this. We've actually added in the interact function. Okay, next, in the event graph, right? I want to override the event interact, right, for the event graphs. Let's do that. So back to the event graph, I want to double click on interact, which gives me this event interact. I don't care about these right now. So for now, I'm just going to get rid of these. Okay? So we don't need them. So delete. And all I care about is this. So this event is interesting because I want to check to see if the door is open. If it's true, then if the door is open already, if it's true, then set the door to closed. If it's not true, then set the door to open. Okay, that's the first thing. So I'm going to check to see if the door is open. It's a toggle, right? So branch, right? If the door is open, then what I want to do is, if it's true, I want to set the door open, right? If it's false, I want to set the door closed. So that's what it's going to be. So if it's open, close it. Otherwise, open it. Open means this is positive. It's true if it's open, right? This means it's false, not open, right? Okay, next. I want to show this, and there's going to be two timelines that I'm going to be using. We've used timelines before, remember? Right? So let's make two timelines. One is going to be called door closing. The other one's going to be called door opening. So let's do that. So I'm going to make a new timeline, add timeline. And we're going to call this door closing. I'm not going to modify the timeline yet, just making them. And this one's going to be door opening. So add timeline, door opening. Here we go. So two timelines. For now, we're just coding, and we're going to come back to these in a second. Okay? And now what I want to do is I want to take that static mesh, right, object, which is our door. This is the door object. And that door object, I'm going to set the relative location. And now it says, see how it says rotation Z? But we don't have that here, is because we can't get that until we set our timeline. So if I double click on the timeline here, then we have this track, right? And the track is going to be a float track, right, called rotation Z. And we want to add that to both timelines. So I'm going to go back to the event graph. Notice I have rotation Z here now. I'll do the same thing for this one. I'm going to go double click on it and I'll add a new track, float track. We'll call this rotation Z. right? Once I've added that track, if I go back, you can see that, oops, if I go back, you can see that in the event graph I have this extra output, right? And then what I can do is I can set relative rotation twice. I'm doing it different ways, right? So again, you might think that, and you might be right, set relative rotation, right? Here's my static mesh. It kind of did it for me. But I set my relative rotation to this new rotation. But I can't do it because this is 1. So what do I need to do? Split struct bin, right? So then I can do this. And because I've kind of done it here, I can connect this on update. So this connects to the update execution pin, like this. And what I can do is just get rid of this for a second. And I'll just do this, copy paste. So if I'm copy pasting, in your mind, you should think, wait, is there a better way of doing this? Could I not write a little function for this? The answer is yes, but there's only 2 things I'm doing, right? I mean, like literally I could write a function, but it would be just these 2 things, right? So I wouldn't save much, is all I'm saying. Compile and save. Now we need to define a couple more things for our timeline, right? For the door closing, there's 2 keys. The first one is 0 minus 90. And then 1, 0. Let's try this. So the first one. So new 2 keys. So I want to add a new key. Add key. And the first one is 0 minus 90. That's the first one, right? That's our first key. And we'll add another key, right? And the next key is going to be 1, 0. So this is 1, 0. And what we're going to see, right, is a bit of a slope. Okay, that's what's happening here. So first key again, if I kind of do one of these and one of those, you can see that it goes like this, from 0 minus 90 to 0. So what does this mean? It means that it's going to go from a negative 90 degrees to 0. And it's going to do that over this curve, right? Now the curve right now is linear, but what I could do is if I go to the top of the curve here and right click on the curve, I can make it so that it is auto. And I can do the same thing for the bottom. I can click auto, and this creates a curve as opposed to linear. And you can change the curve if you want it to like smooth in and out. That's what this will do. So compile and save. Again, this is a motion graph. And I always think about, you know what I think about? I think about Joss when it comes to motion graphs. He loves motion graphs. Like every one of my friends at, wait, that's the door closing, right? And the door opening is here. So this is the door closing. And let's go to the door opening. I'll do the same thing. So door opening, add a key. And the door opening is 0, 0. So this is where I'm the 0 time. It's 0 as a value. And then I'm going to add another key. And this value is going to be 1 and minus 90. So it's going to be swinging the door open. All right, and again, I can do kind of one of these. And so I can see what it looks like. This is what happens to it. And on the bottom, I can change it to auto. And at the top here, I can change to auto. And now I have a curve. Compile and save. And I can get rid of these 2 timelines because I have everything I need. All right, so that is my event interact. It gets triggered from the server. We did that last time. And this event interact opens, in this case, opens or rotates the door, the mesh. That's what it does, relative to the container that it's in. Now, what we want to do is let's add some doors to the level, right, to test to see if the sphere trace works. So what I want to do is go back to the level, right? And now that I have some doors, I want to fit them in this nice little place. And luckily, KKit allows me to fit the door exactly where I want it. So it's pretty good in terms of fit. There we go. And we can make it so it kind of goes in a little bit. And there we go. There's the door. Yeah, that's fine. All right, so there's a door right there, and let's see if we can interact with it first of all. So press play, and I have my main character, and they run away, and they go to the door, and if it's interactable, oh yeah, look at that. I get this magenta sphere, which means it's definitely an interactable. If I press the E button, then what I want is when I press the E button for it to interact. That's what I want it to do. I haven't set that up yet, right? Why? Because if you look at the MP character, this is this. It's perform interact on server, right? And that is what's happening right now. So let's see what's happening and why it's not interacting, right? So perform interact on server calls the interact event. Let's make sure that that does that. So here's perform interact on server, and it don't call the interact event. Let's try that. So what we want to do is we want to call interact, right? To do the interaction, right? So here's something. How can I call the interact? Well, I could call it on the interactable actor, right? So here's the call interact, right? And you can see that when I do that, whatever the interactable actor is, doesn't matter what it is, it'll call their version of the interact function. So if I go to here and I go there, and if I press E, then it should swing the door, but it swung it in a weird way. Let's take a look, right? So it kind of did it in a weird way. Like, look at this. Can it swing more? Right? Kind of swings it the other way. So I kind of have some weird things going on, right? So why is this happening? It's right in the wall right now. Here, let's see if I can swing it again. There it is. Ooh. So what can I do differently? What did I do wrong? You guys can make it work. I can make it swing, right? But it swings like way over in the wrong area. So what did I do wrong? Yes?
The animation curve's going in the wrong direction.
Right? Let's take a look at that and see what's going on. So back to the animation curve, right? Because I made a mistake, right? Back to the wooden door. So door closing, right? Door closing. Let's take a look at that again. It goes from 0 minus 90 is what it should be to 0, 1, 0. Does that look correct? Door closing, that looks right. Right? From 0, for the 0th second, takes 1 second for me to close the door. That goes back to 0, right? So that didn't work. That's right, actually. And then what about door opening? Door opening starts at 0, 0 and goes to 1 minus 90. So this is good. But if I go to the viewport and if I look at the door, static mesh, right, there's a couple problems, right? What I did was I made this remember I said I was going to make it my default. What if I don't want to, right? I want to not make it my, I want to drag it, so I don't want this to be my default, root component. How do I undo this? How do I take it away from making it the root component? So we dragged it up here to make it the root component. So what can I do to drag it to not make it the root component? How do I do that? Yes? Okay, let's try that. That doesn't work. Well, we know what we have, right? We had before, just to let you know, right? We had a scene component, right? And that scene component was the root component. It was actually called root component, right? Something like that, right? That's what it was. So the root component was this. So I can kind of make it this way. So I can say that the static mesh, I want this thing to be the scene component and not this thing. How do I do that? Right? Because here's my scene, right? Scene is now a subcomponent of static mesh, but I want the scene to be the root component, not the static mesh component. Okay, there it is. And then now it's the other way around. Okay, so scene is let's actually rename this to root component just so we see this. Root component. It won't allow me to change the name because it's made. Let's call it root. Because root component is, thanks, there's a root and there's static mesh. And static mesh has a 0, 0 kind of thing. And remember that right now it's looking like this. And look at where the pivot point is The pivot point is right here, right? And this is a key indicator of where it is. Did you guys pivot this in the viewport at all? Anybody? Because look at the pivot points here. So this is where it's going to pivot from. Okay? And what I did when I put it in the level, compile and save, when I put it in the level, this is where it's going to pivot from. And it's going to pivot 90 degrees. So let's see what happens when I pivot it manually 90 degrees. So if I pivot it 90 degrees, right now it's pivoted to, let's just do this. It's pivoted to 90 already, right? If I pivot this to 0, it goes like this. This is 0. 0, 0, 0, right? And that's what, and that's what this door looks like when it's in the 0 position, like this. Okay? But that's wrong, right? Because just like what Griffin said, right? This is 0. That's what's going to happen. Our relative location is going to change to 0, which is this, right? So if I left it like this, let's see what happens if I just leave it like this. Let's put this back to where it was, like we're kind of in the corner here, or whatever. Let's undo those changes. There we go. And let's just move this back to 0. So let's just change this to 0, because this is the door, all right? And I'm saying this is the door, it's open. So what happens when I go back to negative 90? So if open, it's open right now, and I can go there, and if I press the thing, it closes. So that's pretty good. That's how it should work. And this is the closed position, and that's the open position, right? But we know it's closed already, right? We know it's closed already. That's what we want. So what we want to do is we want to close it, and we want to move the pivot to the left side, because this is the open position, and we know it's going to move the other direction like this. So this is where it's going to go here, and we want to close this. We want to pivot it by negative 90. There we go. So that's what we want, but we don't see the handle, which is not great from a user interface perspective. We don't see the handle. So just, monkeying around with the door. So now let's see if it works differently. So if I go with my character and I run over there and I go to the door and I press open, now it opens inward. And if I close it, it closes up. So I can actually push the door and it'll open up, right? Well, what happens is it worked the first time, but not the second time? How come? How come it doesn't do the curve anymore? It did the first time, and then somehow I'm able to interact with it even when it's open. Look, I'm able to interact with that actor even if I'm not touching it. That's weird. Yes?
The door opening and door closing go from play instead of play from start.
Say that again?
The door opening and door closing go off of play and not play from start.
Play and not play from the?
Play from start.
Very good. So if I go back to here, to wooden door, and if I go back to the event graph, right? So I went to play, but not play from start. And if you notice my graph, right here, it's play from start, which resets everything. So I want to undo this one, and undo that one, and go into there. Very good. And let's do that again. So I press play, it opens, and if I press play again, it closes. Wait a minute, I shouldn't be able to close that door. And I can, oh man, what the hell? Look, it just does the opposite of what I want, and I can interact with it even when it's open. What happened now? What am I missing now? How come it's not working properly? It's jank. Something's wrong. What's the problem?
I assume the hitbox isn't moving.
Okay, all right, so the hitbox is not moving. Well, let's check to see if that's true. So, but I'm not interacting with it anymore. Look, if it was the hitbox was moving, right, let's try this out again. So here I have an interaction. I can see I'm interacting, right? And here, I'm not interacting anymore, right? So what if I press E again, like way over here? Okay, way over here. Press E. How come? What happened? Well, well. So we have a bit of an issue, right? And the bit of the issue, when I come back to this, 1 second, and let's just go to that piece, is this, right? Where I set my interactable actor, right? So basically I'm saying, is the interactable actor valid, right? And if it's not, what happens, right? Well, I'm doing a sphere trace, remember? So I go back to the interactable actor sphere trace. So here, I'm saying, get the out hit, and here's my impact point. Here's my hit actor. Here's an object, right? And otherwise, I'm returning the interactable actor. Well, there's a false case that I didn't put in. Take a look at this false case right here, right? And I saw this, but I was like, let's see if my friends figure this out. So, interactable actor, which is the sphere trace that I'm doing from here. Here's perform sphere trace, and in here, the false case itself, it's not setting the interactable actor to anything. Well, the false case, if I'm not interacting with anything, then the interactable actor should be null. So I want to do this, and this part right here is going to basically, if it's false, so what I'm saying here is this, get a hit actor, all right? Get a hit out. Here's my out hit. I'm performing a sphere trace. If my hit actor complies with the interface, that's awesome, then true, draw a debug sphere and the interactable actor, set that up to here. But I never unset it, and this is where I'm unsetting it. When I'm not interacting with something, then I unset the actor and make it null. Let's try this now. Compile and save. I'm showing you this stuff because this will mess you up every time. And if I go back to this now, and if I press interact, and if I over here and I click the interact button again, I can't interact again. If I go back to this and I interact again, here I am, then I can close the door. And if I look away and look back, unless I'm close enough, I can't open the door again, right? Oh, that was weird. Here, look. And I'm back to this again, like where I'm doing this again. What's going on there? So this is closed, but this is doing the same thing again, even though it's open. Oh man, what did I miss? I missed something else. And it's weird that my doorknob is like facing away from me when I don't like that. So how do I fix that? How do I fix everything? So I'm having a problem.
The doorknob, I don't think is that hard. You just rotated the actual blueprint.
Okay, the blueprint is what I want to do. But what about the whole open and closed door thing? Does it work the same way for you, like it works for me? Or does it work proper? How does it work, Andrew?
It's the timeline. Since it's playing for 5 seconds, even though it's not.
It's not 5 seconds?
Yeah, it's not 5.
All right, let's go back. So back to the timeline. So back to the wooden door, right? Here it is. And here it is. The total length is 5 seconds, but the whole timeline only lasts 1 second, right? And if you actually look at my graph for a second, for the timeline, right, when you go in here, then notice that the length has been changed to 1 second, right? So that's something we need to do. So change the time length to 1 second, because otherwise it's going to just not, it's going to play out, right? And this is the one part. We do not want this to loop, that's for sure, right? It'll keep on opening and closing. So that's the first thing. What else that we check? Because I also want to check this. So here's the thing. So if door is open, well, door open, it says it's not open. That's good. So by default, the door is closed, right? That's how we had it, right? And this toggle is pretty crappy. Yeah, I'll tell you right now. It's really bad, right? But let's suppose if it's true, if the door is open, we want to close the door. If it's false, then the door is open, and we want to we perform the door opening, okay? So this is correct, but this is weird. Because, I mean, we have to make sure all of our doors are closed by default, right, when we start them off. Otherwise, it'll be weird. It won't work properly. All right, so let's try this again. So open the door, and then close the door, and open the door, and close the door. And what about if I click it really fast? Can I mess it up? No. I can't mess it up anymore. It's good. But I like the way it opens, but I would love if it opened the other way around. Is there some way that I can make it work so it's the other way around instead of this way? Because this is really bad. Because what's happening is, I mean, I can't go through the door, right? But, by the way, if I'm too close, it won't open either, right? I have to kind of be through here. What about if I'm on the other side of the door? It'll close, And the door handle is like over here. I want it to open like from this side, not from this side. So if I'm here, I want it to open up the other way, right? So how do I change that, and what do you recommend? Yes?
Check the player's position relative to the door.
Could do that. Could do that. What about you, Andrew? What are your thoughts? How did you fix it? Did you fix it?
I didn't fix it.
Come on. I expect all you guys to be super smart and fix everything, okay?
The pivot point is on the door handle side.
So the pivot point is on this door handle side, is what you said, right? Okay.
Should it be on the other side?
It should be, right? It's made like this. It's made to like open weird, yeah.
I don't know if this is the simplest way, but I dragged in the door mesh into the scene, then changed to modeling mode and changed the origin that way.
Oh, you're a cheater. Yes, that's definitely a way. You can also pull this into, right. You also can also put this in Blender and change it that way. But the thing, here's something. What about if I was to flip it across the model? I scaled it like -1 across like the x-axis or the x-axis. So if I did like -1, and I did one of those, and then now the pivot point's on this side, right? It's not really. The pivot point didn't change, right? But that, I mean, it flipped the door around, that's for sure, right? So that solved one of my problems. So if I did this and I go back, and if I press play, then does it solve the problem? Well, yeah, I can see the handle now, right? But it doesn't open right. I don't like the way it opens. I think it's crap, right? It's a model issue, is the answer, just like what you said, right? But I fixed the problem with the pivot, right? So again, when I made the door, back over here, I didn't change. I didn't, rotate it at all, right? But you could, if you really want to, and which is what I did, right? So I wanted to make it so that I could see the handle, the way I put it in the, in the level, so it pivots correctly. All right. We did the first interactable. Let's save all, and let's put this up on DevOps. Now we've learned a couple things here, right? We've learned that whenever we want to perform an animation, and this is an animation, right? Because what we're doing with the animation is we're actually moving the door around. We're literally moving things around. And what's positive about this is we want both players to do it. Let's check to see both players can interact with the door, not just one. That's another thing we didn't check. So now we're going to do it with this guy. All right, it's important we do it with both because we might see it with one, but not the other. And let's just do it so we can open the door. That's nice. Now, what about does this one? Does this one see the door open? Hey, that's pretty good, with both opening and closing. All right, well, let's close the door, and now let's see what the other guy sees. Okay, the door is closed on both sides. This is important, that both the doors are opening and closing for both players, right? Because my friends, sometimes if you mess up and if you don't do your interact on the server, it'll only work on the server and not on the client. And the client will have this funky thing where the door seems closed, but on the server it's open. So please be careful about that. All right, last part. And the last part that I want you to do now, and this is your challenge, right, for the last few slides, is this is for you to do. Okay, so I want you to try and do this. I'm not going to do a montage, but I want you to set up the blend space on your own. Okay, you've done blend spaces. We've done it together in the third-person perspective project, right? And for next week, what I want you to try and do is make a blend space for the rogue character, right? There are several animations that you can drag and drop in different points. I've given you the points to the blend space right here, okay? And what you're going to do is you're going to create an animation blueprint, ABP MP character. And what you're going to do with the animation blueprint is you want to promote the following variables, character, and all this kind of stuff so we can see them inside the animation blueprint: character, movement component, and character speed, right? And what you want to do is you want to drag and drop, because all we're doing is one animation in the main thing. There is no animation switch. We're not switching between one thing or another. There's no switch case. All right, as an example, we're not doing that. There is no animation anything. All it's going to do is walk, run, okay? And it also can jump, by the way. But there is no jump animation right now. We're going to add the jumping animation later. All right, and then what I want you to do is after you do that, test it out. And I want you to see if, and here's the test for you, if both players can see the person move. Can each player see the other player perform their animation, the blend sticks? And if not, how can you fix it? Okay, that's your challenge. And that's all I'm going to do for today. When I come back next week on Thursday, we'll be remote next week, just to remind you. Wednesday and Thursday we're remote. Friday I'm in person because at 12 o'clock to 3 p.m. on Friday because Global Game Jam for those people who want to be here. Okay? But Wednesday, Thursday next week, remote. It's a remote week. Okay? And that's it for me today, guys. Good luck. I want you to check it out. I recommend you spend some time today doing it. It'll help you, because what it'll do for you is it'll show you how things are replicated and make sure that things are working. Okay? That's it for me, guys. Thank you so much, and I'll see you next week. And I'll say actually tomorrow I will see you online, right? At normal time. Big lecture tomorrow. Be prepared for lots of coding. Okay?